Picture this. It's 2035. An astronaut working at Shackleton Crater looks across the lunar South Pole and sees lights glowing on the horizon. Not stars, but the unmistakable glow of a nuclear reactor powering a permanent base. But an important question lingers. Will that be our reactor lighting up the darkness, or China's? About a month ago, NASA Acting Administrator Sean Duffy sent shockwaves through the space community with a 60-day directive. Fast track a 100 kilowatt nuclear reactor to the moon by 2030. Not 40 kilowatts as previously talked about, 100, and not eventually, by 2030. Because make no mistake, we are in a new space race. And this time, the finish line isn't about planting a flag and coming home. It's about who gets to stay, who controls the resources, and ultimately, who writes the rules for humanity's expansion into space. The race isn't just heating up, it's gone nuclear. It's high noon at the lunar South Pole. The temperature is a balmy 250 degrees Fahrenheit, but in 12 hours, when the sun disappears for the next 14 Earth days, the same spot will plummet to minus 410 degrees, colder than liquid nitrogen. How will our astronauts survive? Solar panels? Useless without the sun for 2 weeks. Batteries? They need to be the size of buildings to last 14 days. Chemical fuel? You'd burn through your entire supply in days. This is why nuclear isn't just an option for permanent lunar presence, it's the only option. As Simon Middleborough from Bangor University puts it bluntly, nuclear is the only option to power a moon base. Solar panels won't work, diesel generators won't work, and the old-style radiothermal generators just aren't big enough to pack a punch. But nuclear power isn't just about keeping humans alive, it's a complete game changer. First, it enables 3D printers running 24/7, turning lunar regolith into habitat modules, landing pads, and infrastructure. No more waiting months for supply missions from Earth. Second, autonomous mining operations, excavating resources like water ice from permanently shadowed craters, water that becomes drinking water, breathable oxygen, and most critically, rocket fuel. And third, life support systems that can keep humans alive indefinitely, not just for short visits. Michelle Hanlon from the For All Moonkind Foundation explains it perfectly. A small lunar reactor could operate continuously for a decade or more, powering habitats, rovers, 3D printers, and life support systems. Nuclear power could be the linchpin for long-term human activity. NASA's target is a 100 kilowatt reactor that can operate autonomously without refueling or physical maintenance for a decade or more. These systems use enriched uranium fuel, similar to naval reactors, but engineered specifically for the vacuum of space and extreme temperature variations. The reactor core generates thermal energy that's converted to electricity through closed-loop power conversion systems, designed to handle everything from cosmic radiation to moonquakes. The convergence of technologies, nuclear power, autonomous manufacturing, and resource extraction doesn't just enable a lunar outpost. It creates the foundation for what experts are calling a scalable lunar economy. The moon transforms from a destination into a logistics hub for further space exploration and resource acquisition. Everyone talks about the race to Mars, but they often forget Mars is 140 million miles away on a good day. The moon is 240,000 miles away, every single day. Whoever controls lunar infrastructure controls the gateway to everywhere else in the solar system. Mars doesn't matter if you lose the moon first. So, what exactly is up there worth fighting over? Let's start with the obvious: water. The lunar South Pole contains billions of tons of water ice, locked in permanently shadowed craters that haven't seen sunlight for billions of years. Water that can be split into hydrogen and oxygen, rocket fuel. But why refuel on the moon? Earth's gravity well requires enormous energy to escape. The moon's gravity is only 1/6 of Earth's. A rocket that refuels on the moon can carry 6 times more payload to Mars than one launching from Earth. The moon becomes humanity's first gas station in space, turning Mars missions from barely possible endeavors into achievable next steps. Then there's helium-3, The moon holds over 1 million tons of this rare isotope that's virtually non existent on Earth, but abundant on the lunar surface thanks to billions of years of solar wind bombardment. Helium 3 is the holy grail of nuclear fusion, clean energy with minimal radioactive waste. We're talking about energy densities that could power our exponentially growing data centers, enable massive desalination projects, and provide the industrial energy needed for carbon capture at scale. Finally, the kicker: rare earth elements, the hidden foundation of modern civilization. Neodymium for wind turbine magnets and electric motor permanent magnets, dysprosium for high performance magnets in cars, europium for LED phosphors, terbium for solid state lighting, yttrium for superconductors. The same materials that make your smartphone work, enable renewable energy infrastructure, and power our most advanced military systems. Right now, China controls 80% of global rare earth processing, virtually giving them a chokehold on everything from F 35 jets to Tesla batteries. Lunar mining could break that monopoly entirely, securing supply chains for critical technologies. George Friedman put it best: he who controls the moon controls Earth. The moon is the ultimate high ground, offering everything from resource wealth to strategic positioning for cislunar space operations. And here's why we're in a rush. First mover advantage is everything in space infrastructure. The first nation to establish permanent, reliable power on the moon doesn't just get bragging rights, they get to shape the operational norms for everyone who comes after. As one strategist warned, early actors could declare a de facto keep out zone, limiting the United States' options to site its base. Sound familiar? It should. It's exactly what China did in the South China Sea. Imagine if the American frontier had been settled without any law enforcement, any property rights, or any rules about who could stake claims where. That's essentially where we are with lunar development right now. The legal framework governing space activities dates back to 1967, the Outer Space Treaty. It's a Cold War document that bans national appropriation of celestial bodies and requires peaceful use of space. But it says virtually nothing about long term operations, resource extraction rights, or how to handle competing claims to the same valuable real estate. That legal vacuum is being filled by whoever acts first. As one expert warns, in the absence of rules, today's actions may become tomorrow's precedent. The United States tried to address some of this with the Commercial Space Launch Competitiveness Act of 2015, which grants private companies rights to extract and own space resources. Senator Ted Cruz explained the logic. You don't own the ocean, but you can own the fish you catch. The Artemis Accords extends this principle internationally through the idea of safety zones. NASA's Mike Gold says that safety zones are not about ownership. They're about transparency and deconfliction. But China isn't a signatory to the Artemis Accords. They advocate for UN-based governance while simultaneously building infrastructure that could establish de facto territorial control. It's the South China Sea playbook all over again. Build artificial islands, declare them defensive installations, then gradually expand operational control until they control all of the critical shipping lanes. The same pattern could easily play out on the moon, but with potentially even greater consequences. Whoever controls lunar infrastructure controls the gateway to the entire solar system. The UN Committee on the Peaceful Uses of Outer Space does have a legal working group through 2027, but commercial hardware is already landing. Legal scholars are still wrestling with fundamental questions. Can you establish operational zones around critical infrastructure? What constitutes harmful interference? Who arbitrates disputes 240,000 miles from Earth? And while lawyers debate frameworks, engineers are already building rockets, landers, and reactors. The nation that powers up first doesn't just get a technological advantage, they get to shape the legal precedents for everyone who follows. The legal questions aren't the only thing still left open. We need to design a nuclear reactor that can survive a rocket launch, operate autonomously for 10 years in the harshest environment imaginable, and do it all while weighing less than 15 tons, because that's your launch vehicle's limit to lunar orbit. The lunar environment is actively hostile to complex machinery. Temperature swings of over 200 degrees Celsius between day and night. No atmosphere means no convective cooling. All heat rejection must be radiative. Cosmic radiation that would fry unshielded electronics. Lunar regolith so fine and electrostatically charged, it infiltrates everything. NASA's target reactor must generate 100 kilowatts continuously, enough to support about 80 American homes, but on the moon, enough to run life support, manufacturing, and mining operations for an entire base. The reactor core uses enriched uranium fuel, similar to naval reactors, but the power conversion system must work in vacuum conditions with no maintenance for a decade. Unlike terrestrial reactors that can be built and fueled on site, lunar reactors must be fully assembled and fueled on Earth, then transported via rocket. Any failure during launch could disperse radioactive material, so extensive radiological contingency plans are mandatory. Once on the lunar surface, the reactor must be capable of autonomous startup, operation, and emergency shutdown without human intervention. From China and Russia, the pressure is immediate and real. China's Chang'e 8 mission launches around 2029, testing the exact in situ resource utilization technologies their nuclear plant will rely on. This isn't just another mission, it's a full dress rehearsal for permanent infrastructure, demonstrating to the world that China can extract and use lunar resources at scale. The mission will carry payloads from 11 countries and regions, plus one international organization, all operating under Chinese control and Chinese timelines. Combined with Russia, they plan a joint lunar nuclear plant by 2035, integrated with their International Lunar Research Station that already has 17 countries and organizations signed up as junior partners. 5 years might not sound like much, but in space infrastructure, it's the difference between setting precedents and following them. The nation that demonstrates reliable nuclear power first establishes technical credibility, operational norms, and most importantly, strategic positioning for everything that follows. Let me paint you two different pictures of 2040, and you tell me which world serves American interests. Scenario 1. American nuclear reactors power the moon's economic hub. SpaceX launches supply missions. Blue Origin operates mining equipment. American companies extract helium-3 and rare earth elements, breaking China's stranglehold on critical materials. Our allies, Japan, Britain, and Canada, contribute technology while sharing in the profits. American entrepreneurs develop new industries we can't even imagine yet. The moon becomes the engine of American economic and technological dominance for the next century. Scenario 2. Chinese nuclear reactors power everything. American companies need Beijing's permission to land on the moon. SpaceX becomes a logistics contractor for Chinese operations. Tesla's electric car batteries depend on rare earth elements controlled by Chinese mining operations 240,000 miles away. Every American Mars mission requires Chinese approval to refuel. China doesn't just dominate space resources, they own the gateway to humanity's future, and they decide who gets to walk through it. This isn't speculation, this is China's documented playbook. Look at what they've done on Earth. They strangled rare earth competition by dumping prices until foreign companies went bankrupt, then jacked up prices and restricted exports. They banned rare earth sales to Japan during a territorial dispute, crippling Japanese electronics manufacturers. They threatened to cut off rare earth supplies to American defense contractors. In the South China Sea, they built artificial islands, claimed them as territory, and now control shipping lanes worth $3 trillion annually. This is exactly what China will do on the moon, but with much larger consequences. Ouyang Zuan, director of China's moon exploration program, doesn't hide their intentions. The first nation to conquer this area will benefit first. Not explore, not cooperate, conquer. Meanwhile, China's space program excludes American participation entirely. Their International Lunar Research Station, it's designed specifically to create an alternative to American leadership in space. The 17 countries they've signed up aren't partners, they're clients dependent on Chinese infrastructure and Chinese goodwill. Compare that to American space leadership. When America dominated the moon in the 1960s and 70s, we shared our samples with 135 countries. When we built the International Space Station, we included former enemies like Russia. When SpaceX revolutionized space launch, it reduced costs for everyone on the planet. American space leadership has meant open markets, shared technology, and rising tides that lifts all boats. Chinese space leadership means controlled access, restricted technology, and benefits flowing to Beijing first. The economic stakes couldn't be higher. The moon's resources are worth trillions of dollars. If China controls them, they don't just break America's technological edge, they gain the economic leverage to shape the global economy. Imagine China controlling not just 80% of rare earth processing, but 100% of space based resources. Every advanced technology, from quantum computing to fusion reactors, would depend on Chinese approval. This isn't about competing systems anymore. This is about whether America remains a technological superpower or becomes dependent on Chinese space infrastructure for our most critical supply chains. Here's the hard truth: America has everything it needs to win this race. We have the world's most advanced commercial space industry. SpaceX and Blue Origin have revolutionized launch capabilities. We have the world's best nuclear technology. Companies like Westinghouse and BWX Technologies lead in advanced reactor design. We have a coalition of 40 plus allied nations through the Artemis program, while China has to bribe countries to join their program. We have every advantage except the most important one: political will and sustained funding. NASA's current budget is probably not sufficient for the ambitious timelines we're facing, especially when we're competing against China's essentially unlimited state spending. In fact, the situation got even worse, with Trump's proposed 2026 budget slashing NASA funding by 24%, from 24 billion to 18.8, the largest single-year cut in NASA's history. I've covered this budget crisis in detail in other videos, but the bottom line is clear. We're asking NASA to win a space race while cutting their resources by nearly a quarter. Meanwhile, China's space program gets basically unlimited funding from a government that views space dominance as a national security priority. They don't worry about election cycles or budget battles. They don't give speeches about the importance of space while cutting funding. They set a target, fund it until completion. The Idaho National Laboratory's analysis is crystal clear. Success requires centralized, top down leadership, large and stable multi year funding, and sustained urgency. They literally reference the Manhattan Project as the model for what's needed. But instead of a Manhattan Project, we're getting budget cuts and bureaucratic delays. And instead of treating this as a national security emergency, we're treating it as just another NASA program subject to political whims. We need immediate action. White House level coordination treating this as a national emergency, not a NASA science project. Military level funding and urgency. This is about American technological supremacy, not just space exploration. Public private partnerships that leverage American commercial advantages. Let SpaceX handle launch. Let private companies compete for reactor design, but fund them at the scale needed to win. Let me take you back to the scenario I opened with. It's 2035, and an astronaut stands at the lunar South Pole. But now you understand what's really at stake when they look across that stark, airless landscape. They're not just seeing lights from a nuclear reactor. They're seeing who will control the next phase of human civilization. If those lights are Chinese, America becomes a junior partner in humanity's expansion into the stars. Our companies operate at China's pleasure. Our access to space resources flows through Beijing's approval. Our children will inherit a world where the most important supply chains are controlled by a foreign power that sees America as a strategic rival. If those lights are American, we secure not just our place in space, but our technological and economic dominance for the next century. We break China's rare earth monopoly. We ensure space remains open to innovation and competition. We guarantee that humanity's future among the stars reflects American values of freedom, entrepreneurship, and open markets. The choice isn't just between America and China. It's between an open space economy that benefits everyone and a controlled space economy that benefits Beijing. This is our generation's defining moment. The first space race proved America could achieve the impossible when we set our minds to it. This one will determine whether America remains the world's technological leader or becomes dependent on Chinese infrastructure for our most critical needs. The future isn't watching anymore. It's happening now. And right now, while we debate budgets and timelines, China is building the future they want. America must lead in space Because the alternative isn't just Chinese dominance, it's American irrelevance in one of the main domains that will define the next century of human progress. The reactor that lights up the South Pole in 2035 will illuminate either American leadership or American failure. The choice is still ours to make, but not for much longer. Thanks for watching, and if you found this valuable, consider liking and subscribing so you don't miss future videos. I'll see you next time. Alrighty. Some good mate. Anyone want to sponsor me?